Back to Mathematics by AC Okocha. I'm so excited that we are making a lot of progress in inequality because this topic can be very confusing. There are too many ways you can solve a particular question in inequality, but sometimes some of those methods involve trial and error method. But I've been showing you a very certain method that will help you get your answer without any element of doubt. Now, we have an algebraic fractional absolute value inequality. How do we go about this? I believe by now you should have an idea of what we're going to do. It's going to take a couple of processes, but we'll get there. Now remember that anytime we have absolute value sign in one side and we don't have in the other side, what do? We take what is inside the absolute value, the way it is. Let me just go ahead. Instead of saying it, let's go ahead. So we have here 3 minus 5x over 2 minus x is greater than or equal to 2. That is the first possibility. Remember, now the next possibility is 3 minus 5x over 2 minus s is less than or equal to minus 2. You know that. So the first one, you write it the way it is without the absolute value sign. Then the second possibility, you reverse the inequality, multiply this other side that doesn't have absolute value sign with negative. Are you following? So those are the two possibilities. I've already explained that before, so that should not be a problem. Now let's take it off from there. So we're going to solve each of these. And remember how we go about solving this. We are not going to cross multiply because this is a variable in the denominator. I said when you have a variable in the denominator, don't cross multiply. Instead, multiply both sides with what you have with the square of what you have in the denominator. So this is where we are going to now. 3 minus 5x over 2 minus x times 2 minus x squared then is greater than or equal to 2 times 2 minus s squared. That is for this side. For this side is the same thing. Maybe we'll solve it one after the other. 3 minus 5x over 2 minus s times 2 minus x squared is less than or equal to minus 2 times 2 minus s squared. That is for this side. Now, when this one cancel one of these, this cancel this, it remain 1. So we have 3 minus 5x times 2 minus x. This one come to this side, become minus 2 brackets 2 minus s squared. Let's just solve this one down. So we have what is common here, 2 minus s. 2 minus s is outside. What will remain inside here? It will remain 3 minus 5x. Then what will remain here? It will remain minus 2 brackets 2 minus x, because 2 minus s is already out. So we have 2 minus x bracket 3 minus 5s minus 2 times 2 minus 4 minus 2 times s plus 2x, which will summarize as 2 minus s bracket minus 5s plus 3 plus 2s will give us minus 3s, then minus 3 plus 4 minus 1. Are you following? Okay, there is greater than or equal to here 0, greater than or equal to 0, greater than or equal to 0, greater than or equal to 0. Are you with me now? So let's solve this one down like that. Or there is still or coming down. So it's the same procedure. Here we have this will cancel this. We have 3 minus 5x times 2 minus x. When this one comes, you have plus 2 times 2 minus x squared is less than or equal to 0 now. Good. So we have what is common here? 2 minus s. If 2 minus x is outside, what will remain inside? It will remain 3 minus 5x, then plus 2 bracket 2 minus x is less than or equal to 0. So we have 2 minus x, 3 minus 5x, open this bracket, you have plus 4 minus 2x is less than or equal to 0. That will give us 2 minus x, then minus 5s minus 2s will give me minus 7s, then what do we have there again? Plus 7 is less than or equal to 0. So from here, we are going to draw a long number line to represent it. Follow me carefully. This is x. Oh, we've not gotten the critical value. What are the critical value? Critical value. S is equals to, if we saw this equals to 0, S will be equals to 2. And S will be equals to what? If we solve this equals to 0, S will be equals to minus 1 over 3. That is the critical value here. Or critical value here. Critical values here. If you solve this equals to 0, S will be equals to 2. And if you solve this equals to 0, S will be equals to 1. S will be equals to 1. Now, let's pick up the values. Now, there is something important I need to say here that I did not say when I started. You see, S minus 2 minus x, S can never be equals to 2, because if S is 2, this denominator is 0. That means it's undefined. So take note that S is not equals to 2. Take note of this. Have it at the back of your mind. Because you are seeing 2 here and 2 now. S equals to 2, S equals to 2. So you need to know that S will not be 2. So when you are drawing that of 2, let's start with the least one there. That is 1 over 3. This is minus 1 over 3. Minus 1 over 3. Then after that, we have we have 1. We have 1. We have 2. We have 2. You are not going to write 2 times now. So we'll just have 1, 2. Are you following? Now look at this, because this is where the thing gets very confusing to some people. Let's represent this. Don't worry, you'll see how we'll get the answer now. Let's represent this 2 and minus 1 over 3. That is this and this. When you move from 1 over 3, you can shade it. If you stop here now, you can shade, because we know that S is also equals to minus 1 over 3. But we know that S is not equals to 2. So when you move from here, don't shade the 1 of 2. Are you seeing what I'm doing? Don't shade here, because already we know that S cannot be 2. S is not equals to 2. So you don't shade the 1 of 2, but you shade 1 of 1 over 3, because S is equals to 1 over 3. It's a valid addition. Now, let's represent that one. Let's come here and check this region before minus 1 over 2. Let's put minus 2 here. If you put minus 2 here, you have plus. If you put minus 2 here, you have plus. Plus 6 minus 1 will still give you plus. Plus times plus is plus. So this region is plus. This region here at the center will be minus. This region here will be plus. That is the first. You can check 3, this region. Put 3 here, minus. Put 3 here, minus, 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 minus. Minus times minus, plus. Now, what does this say? This say greater than 0 or greater than or equal to 0. That means anything greater than 0 is positive. You go to this direction. And you go to this direction. Are you seeing it? That is the first. This one now just represented. Now let's represent this one, which is 1 and 2. Let's move from 1. Let me move this minus. Let me move it here. Let's move from 1. I don't have my T-paste here. If you move from 1, take it up a bit. Remember that S can be equals to 1. S is equals to 1. You shade it. But S is not equals to 2. So when you go up for this one, you also don't shade it. Don't shade because S is not equals to 2. Are you with me? Now let's check this region now. From here to here, from here to here, from here down to infinity. So this region, less than 1, you can check here. Anything less than 1, you can put 0. Put 0, here is 2. Put 0, here is 7. That is plus. So this region here now is plus. So here will be what? Minus. While here will be what? Plus. Are you seeing it now? Now, for this one, it's less than. Less than means they go towards negative. Anything less than 0 is negative. Less than or equal to. So you move like this to the negative direction. Are you seeing it now? So this region is valid. This region is valid. And this region is valid. So how do you present this answer? There are a number of ways you can present this answer. But let me start with this method first. We can start by saying that minus 1 over 3 or S is less than minus 1 over 3. S is less than or equal to. S is, take it again. S is less than or equal to minus 1 over 3. Don't mind me. God. I'll do it again. S is less than or equal to minus 1 over 3. Or this one means 1 is greater than or equal to, or if you are writing it like this, you call it less than now, x less than 2. That is the joining of this from here to here. Then from here to here, or s is greater than 2. Can you see it now? Yes, that is it. If you are using this method, you say that this is another method. You say that S is a member of from negative infinity to minus 1 over 3 inclusive union from 1 inclusive from 1 inclusive from 1 inclusive to 2 not inclusive, then union from 2 not inclusive to positive infinity. This is how another way to present this. Does that make sense? Okay. To some of you now, you say, this is log. It's not log. It's because I'm explaining and teaching. Stop looking for shortcut. Just know it. As I am now, I know that this is perfect. The answer cannot be wrong. It's better to be long and correct than to be short and wrong. In fact, most people that use that short method, 80% of them end up failing it because the work is getting this answer. You can get the values. You can know that it's maybe 1 over minus 1 over 2, 1 and 2. That is not the problem. It is getting the answer, knowing how it will look like, getting the right range. Some people will go and rearrange it. So this is for it. See you in our next class.